Hi, this is project group number 143, and our topic is Morse code audio to text using RNN LSTM networks. Now, our motivation is our project focuses on Morse code, which remains essential for emergency communications when other systems fail. Currently, decoding requires specialized training for equipment. We aim to develop a system that automatically converts Morse code audio into readable text, making it accessible in emergencies without expert knowledge. This is especially relevant today as natural disasters emphasize the need for reliable backup communication systems. And the length of a dot is 1 unit, a dash is 3 units, and the space between the parts of the same letter is a 1 unit. This is how the data is recognized, and you can see from A to Z we have dots and dash, and for B we have dashes, dots, and dots. And the numbers goes like from 1 to 0, it changes for each number. Now, the source of data is a continuous wave manually generated via an application. The inputs are alphabets and numbers, and the outputs are words and sentences in emergencies. Our inputs and output files will be explaining in the next slide. Now, here we have a continuous wave that's dashes. Here we have a continuous waves that's dash and dots, and which is being converted into a sentence using alphabets over here to convert the sound signal Morse to text. Here is our metrics for the evaluation. So the accuracy measures how well the model is identifying the correct Morse code characters. The loss represents how well the model predictions matches the true labels, with lower values indicating better performances. Validation metrics during the training, both validation and training metrics are tracked to ensure that there's no overfitting to the training data. Early stopping can be used to halt the training if validation accuracy stops improving. Now, here's a great diagram for our signal analysis and how the spectrogram is converted to the timing and how we are converting these into our sentences. The methodology is data generalization, Morse code to audio, spectrogram, and the model architecture is CNN, RNN, LSTM networks. Now, here audio processing is MFCC extraction, sequence to sequence learning approach, data augmentation for rare symbols, training validation split is 80 by 20, and evaluation metrics is accuracies and the losses that we encounter. The baseline neural network architecture that we have is two CNN layers extract patterns from Mel spectrogram. Then max pooling layers are used to reduce the dimensionality after each convolution. A fully connected LSTM layer processes the sequential nature of the audio data. A dense layer with softmax activation outputs the probabilities for each Morse code character. The baseline performance, the model was trained on a data set of audio files representing each letter from A to Z. The model was able to achieve around 60% of the accuracy during the training phase. The challenges that we faced were the dataset size was relatively small, that is 100 audio files, and more data would be required for a better generalization. The model showed improvement over epochs but could still benefit from a more complex architecture and fine tuning. The improvised RNN LSTM model architecture that we have is a four RNN layer extract patterns from MEL spectrograms, and a fully connected LSTM layer processes again the sequential nature of the audio data. And we have increased the training size of the audio files from 100 to 500. Here we can see the training accuracy is a 99.5% curve. The validation accuracy curve is an 87.7%, and the best validation loss is a zero point 0.4 at epoch 44. The limitations and future work. So, current limitations are struggles with complex character combinations, performance issues with similar patterns, occasional confusion in noisy sections, and our future improvement, our attention to mechanisms, more diverse data augmentation, transformer based architectures. And here are our prior experiences. Me, Dhanush, and Dhanashri have all been experienced with neural network LSTM implementation. And we come from a diverse skill set that motivates us to work on this project. Here are our references that we used for the data set and from different websites like Play Morse, Morse Code International Standard. Some images used in this presentation also were sourced from these websites, remaining the property of the respective owners. Thank you so much.